Hello class, this is a video tutorial on permutations part 1. In this video we'll be looking at the general concept and the notation. Factorial notation is used to quickly calculate how many arrangements from n objects can be made without repetition or replacement. So for example, let's say that there were 10 competitors. How many different ways can this race finish? In first place, there are 10 possible people who could come first. In second place, because one of them are now in first place, there's one fewer who could come in second place, and so on. So there's first place, there could be 10 people, second place can be 9, 8 for third, and so on. And we saw that we could easily write this as 10 factorial. A key condition that I'd like to draw your attention to is actually that in these instances, pretty much every single example we've done so far, is that order matters in how we've arranged them. So for example, let's say this is the race here. Adrian coming first, Bob coming second, and Charles coming third, with Dave coming fourth, is different if Adrian comes first, and then Charles comes second, Bob comes third, and Dave comes fourth. Even though the same competitors have come first, second, third, or fourth, it's very distinct who comes second and third in each of these examples. The order matters. So this is different to this one. They are unique arrangements. It'll be very important later that this idea is going to be differentiated. So a permutation is an ordered arrangement. So everything we've done so far is a permutation. It is an ordered arrangement, and we could represent it as 10 factorial or even using the indices. Now, what if only a few objects will be arranged? So for example, from the 10 competitors, only the first 4 winners will move on to the next round. Their position in the race determines their start position of the next round. So I presume in this example, if someone comes first in the current race, the position that they are in for the next race is somewhere near the front. So it's beneficial to come first. So in this case, let's figure out how many objects there are and how many positions are available. I've actually already filled it out here. The objects that we can choose from are the competitors. There are 10 possible competitors or objects. The positions that we are offering, or we have to place them into, there are only 4 because only the first 4 winners matter. Well, it's going to be the exact same way. In this case, we have 10 people who could come first, 9 people who could come second, 8 people who could come third, and 7 people who could come fourth. And we do not worry about the remaining competitors, because we only worry, in this example here, we only worry about the first 4 as outlined in the description. Well, as we saw, there's an easy way to represent this. There's actually an easy way to represent what we're showing here. So the notation for placing n objects into r positions is called P for permutation. N, P, R. So n is the total number of objects we can pick from. R is the number of positions we want to place them in. We can summarize this as n factorial over n minus r factorial. N, well, if we want to do this, this can be written as 10p4. We can write this as 10 factorial over 10 minus 4 factorial, which is 10 factorial over 6 factorial, which is what we have here, 10 times 9 times 8 times 7. Now, if we want to easily find the actual numerical value of that, we just simply type it in, 10, and as I've outlined here, that symbol is usually above the multiplication symbol, so you press shift times, you get that P, so that's 10P, and we want 4. That gives us 5,040. I mean, you could type it in manually just to double check. So 10 times 9 times 8 times 7, we get the exact same thing. So we have this new notation that we can think of. Yeah, so remember, NPR is N total objects, P is for the permutation, and R is the number of positions that we have to place them in. The important details are, this is with only no repetitions and order matters, and this is not completely different from factorial notation. It's just that factorial notation takes all 10 competitors in this example, so this is where we would use factorial notation because all of them matter. Whereas this notation, P or pick notation, only a certain number matter. So let's do a few examples. You can go ahead, pause the video and give them a go yourselves. So here we have just 2 examples, and here we go. A 5-character password is to be made using the letters of the alphabet and the digits. How many different passwords can be formed with no restrictions? Well, let's think about this first. How many letters of the alphabet are there? Well, there are 26 letters, and the digits, as we've seen in previous examples, there are 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. The digit number 10, excuse me, the digit number 10 is just a combination of 1 and 0, so that's not actually counted. So in total, we have 36 total objects we can pick from. How many positions can we choose, or well, place them into? Since it's a 5-character password, we have 5 positions. Now in this first example, it says there are no restrictions. That means this notation, remember, it's no repetitions. Because it says no restrictions, that means we can repeat. So we can't use this notation. So let's think about this. In the first position, we could choose from 36 possible characters. So all the letters and all the digits. In the next one, because there are no restrictions, we could choose from 36 again. And the same with the next character. There are no restrictions, so we could choose from the 36 again, and so on. There's our 5-character password. This will give us 1, 2, 3, 4, 5. That is 36 to the power of 5. So this, just to be very clear, this is still a permutation because the order matters. So for example, a password of A, B, C, D, E, that is a different password to A, C, D, B, E. Even though we've mixed up the letters, this password is different from this password. The key definition for a permutation is that order matters. It's just that in this example, this is not using this notation. Okay, so in this notation, the restriction is no repetitions. Now let's take a look at this next example. It's the exact same thing. We still have the 36 total objects, and the 5 possible positions. But now this time it says no character can be repeated. So no character can be repeated. This has no repetitions. Whoops. Now let's take a look. Here are our 5 positions. 1, 2, 3, and 4, 5. In the first position, we could choose from 36. In the next position, because we can't repeat characters, there are only 35 left. In the next character, there are only 34 left, 33 left, and 32 left. This one we can write as 36p5, which if we summarize it using the definition of it, this one here, n factorial divided by n minus r factorial, it's going to be 36 factorial over 36 minus 5, which is 31 factorial. So we can leave it like this or like this. Entirely up to you. You could type it into your calculator. 36 p5. You can get the actual number, but as you can see, it's a very large number. So I actually prefer to leave it like this or like this. So I hope that gave you an insight into this notation for permutations, and it gave you a deeper insight into what a permutation is. So I hope to see you in the next video. Best of luck.